So now that we kind of understand the definition of pKa and how it has to do with some molecules being better acids and some molecules being worse acids, we're going to have to go over our pKa values now, okay? Now, I don't like to give you guys a lot of stuff to memorize in organic chemistry. I like for you guys to understand it versus memorize it. But it turns out that pKa values are just one of those things that maybe it's just better for you to memorize it. If you can understand it, great. But even if you don't understand it, I think it's worth your time just to memorize them because they're going to continue to help you in Orgo 1 and in Orgo 2. They're that important. So let's go ahead and get started. So here I've given you a basic spectrum of some common molecules that you're going to need to know for your test, for Orgo 2, etc., MCAT, whatever you're taking. And I'm starting off with the worst acids. Okay? Not worse, worst. And then I'm going to go all the way to the best at the end. Are you guys cool with that? So I'm going to start with the worst. And if I'm starting off with the worst, that means these are going to have the highest or the lowest values. What do you think? These are going to have the highest values because they're the worst acids. Remember, I'm going to start off with like the shittiest acids, okay? So let's go ahead and start off with basically sp3 hybridized CH. Okay, I know that sounds really complicated, but all that is that's just another way for me to say alkane. Okay, remember that alkanes are sp3 hybridized because you basically have a carbon with another carbon on it and a bunch of H's. Okay, and what that means is it has 4 groups, and if it's 4 groups, then it's sp3 hybridized. Okay, well, these alkanes are not acidic at all. Think about it. It's because they're not reactive. Remember that I told you guys that what makes molecules reactive? Dipoles, charges, strain, double bonds. Alkane doesn't have any of that, so it doesn't want to be an acid at all. So that means that it's going to have the worst pKa of around 50. Okay, so it really doesn't get worse than an alkane. An alkane is the worst acid. Okay? Then from there, these start to get a little bit better. So let's talk about sp2. sp2 hybridized CH sounds complicated, but that's just another way of saying alkene. Okay, remember what an alkene is? It's a double bond. Okay, so that would be an H coming off of a double bond. All right, now is this going to be a little bit more reactive than a single bond? Yes, because remember I told you guys that double bonds are sources of reactivity. So this is going to be a little bit better, and it turns out that this one is going to have a pKa of 44. Okay, so it still sucks a lot, but at least it's a little bit better than the alkane. Okay, so now we're just going to keep going in order. We're just going to keep going up. So now we have amines. Okay, amines are just any time that you have an H coming off directly of a nitrogen with a single bond. Okay, and anytime you have an amine, that's going to be a pKa of 38. Okay, so it's still really high. Remember that I said 16 is your middle point, right? So we're still really far away from that. These are still bad acids, but they're getting a little bit better. Then we get to H2. H2 is a really important molecule that you're going to need for some reactions. It's just diatomic hydrogen. You don't need a name for it. This one's going to have a pKa of 35. Okay? This one, honestly, there's not a lot to understand. It's just to memorize it. You just need to know that H2 has a pKa of 35. That's going to help you a lot. Then we get all the way down to sp hybridized CH. sp would be an alkyne. Okay? Because remember that sp means that it only has 2 groups or 2 bond sites. So that means it would literally be a triple bond with a hydrogen coming off of it. Okay? Now that triple bond is even more reactive, so it's going to be a little bit better at donating protons. This one has a pKa of 25. So I made a really big jump. That one's getting a lot better. Okay? So if you could group these together, I would recommend always know that your alkenes, and your alkynes are 50, 44, and 25. I'm going to grill you guys on that all semester long. I'm going to be like, remember sp2? Remember sp? That was 44, 25. I'm going to ask you these values over and over again because they're that important. Okay? Then we've got our alpha hydrogens. Okay? What the heck is an alpha hydrogen? Okay? An alpha hydrogen is any H that's coming directly off of a carbonyl, off of the carbon next to a carbonyl. So here I have a carbonyl. This carbonyl could be anything. It could be an aldehyde, let's say. It has an H there. This carbon, if that one has an H on it, that H is going to have a pKa of 20. Okay? Now it turns out that you're not really going to understand why this has such a low pKa, because normally what would be the pKa of a CH bond that's sp3 hybridized? Okay? What would that normally be? It would usually be 50. But now what did I just tell you? Instead, the pKa is actually going to be closer to 20. That's a huge, huge jump. So why is it so much more stable if it's on that alpha carbon? And the reason has to do with a phenomenon called tautomerization. Okay? Now it turns out that tautomerization is something that that I might teach you in Orgo 1, but we really explore it in Orgo 2. Okay? So this is one of those rare times that I have to teach you about something that you're not going to understand right now. And you just have to accept it. You have to be like, I mean, I hate bringing up stuff that you can't understand yet, but in this case, just take my word for it. Tautomerization is this thing that makes the carbon next to a carbonyl much more acidic. Okay? It only has to do with the carbon. That's why I have a star there. It has to do with the carbon next to carbonyl if it has an H on it. Cool. So then we get to some easy ones. So we have ROH, which is alcohol, and water. These both have about the same pKa. They both have a pKa of about 16. Okay? So if you just remember, I told you as water has a pKa of 16, that's the middle point. So this is like the neutral point right here. Okay? It's not really neutral, it just means that I compare all the other acids to it. So remember that I said all the ones before it, these would all be the bad acids. So that means that over here, I'm going to start getting into good acids. Is that cool? Another thing to keep in mind, water actually has a more specific pKa. Your professor might want you to know it. It's 15.7, okay? But that's so close to 16 that I always just round it. I always just say water has a pKa of 16. Cool so far? Now we're going to start getting into the good acids, okay? So what happens if I have a nitrogen with a positive charge, okay? A nitrogen with a positive charge and at least one H on it, actually. So you might want to add that H just so you remember, okay? If you have a nitrogen with a positive and at least one H on it, that is going to have a pKa of around 10, okay? Now you could imagine this is a pretty good acid because look, it has a full positive. Remember that I told you guys that if you have formal charges, that makes something really reactive. So this has a full positive, so that means that that's very electrophilic. That's going to be very much of good acid. Okay? So let's keep going. Then we have all your carboxylic acids. Your carboxylic acids, I'm just going to write that here. I mean, they have acid in the name, right? And carboxylic acids are about 5. Okay? And you would know that because we actually just calculated the pKa of a carboxylic acid. Remember, acetic acid? That's a type of carboxylic acid. And that one was, remember, it was 4.75, 5. So we just rounded up to 5. Is that cool? Awesome. So now we're on the home stretch. So now what if we have an O positive with one H on it, with at least one H? Okay, so you might want to also add that H. What that is that now we have an O positive that's a very, very good acid. That's going to be around -2. Okay, so if you ever see, now we're getting into the negative numbers, that means these are going to be strong acids. Okay, and then finally we have HX. HX is just going to be your strong acids. So remember that I told you, remember your strong 6? 3 of your strong 6 are HCl, HBr, and HI. Okay? These are all going to have very acidic pKa's. And I'm not going to make you memorize those pKa's because most often professors don't care about those pKa's as much because they're all negative. So I'm just going to group them together and just say they're all negative. Okay? If you want to memorize them, if your professor's really picky, maybe he'll make you memorize -11 and -7 and stuff like that. But most of the time, you're fine as long as you know it's just negative. It just means it's really acidic. Is that cool? So I know that was a ton of information, but thankfully I'm going to give you lots of practice so that by the end of this page, you're going to be feeling more confident.